Today we'll discuss about the story of Newton's inverse square law. So, long back, physicists considered that the Earth as the center of the universe. Okay, so but the Polish astronomer Nicholas Copernicus suggested that the Earth and the other planets revolves in a circular orbits about the Sun. And studying the motion of the planets and the stars, the German astronomer Johannes Kepler gave the laws known as the Kepler's laws of planetary motion, which I already told in the previous video. Now we are going to learn this, what are the laws the Kepler said, or you can say the Kepler's laws of planetary motion. So first, write the Kepler's laws of planetary motion. So what is this law? First law, there are three laws are there. First law is planet moves in the planets. The planets move in elliptical orbit. With the Sun as one of the focus or the focal point of the ellipse. So first you have to know that what is ellipse and what is the focal point. See, normally ellipse will look like this one, that is called the ellipse. So remember the circle is having one center, while ellipse is having two. So this is one center, this is one center. Okay, so these two center are called the focus. This is called the focus, and this point is known as the focal points. So what the law says, the planets moves in the elliptical orbit. Then all the planets will move in the elliptical orbit, and the Sun will be at the focus like this way here in this case. So this is the planet. This one is planet, and this is the Sun. Okay, so this is the first law. Next one is the line joining the line joining the Sun and planet covers equal areas in equal interval of times. What is the meaning of this? The meaning is, like, suppose the planet was here. First the planet was here in this position, and after 1 month, in 30 days, the planet will go to here because the planets are revolving around the Sun. So if I join this line, then the area, this is the area. Okay, so this is called the line joining the Sun and the planets covers the equal area. That means when the planet was here, and after exactly 30 days, the planet will go to here. So it will covers this area. Now again, when the planet will come to here, again after 30 days, it will come to here. So again, if I join this line, so this area, so both the area will be same. Okay, so that is called the line joining the Sun and the planets covers equal areas in equal interval of times. Oh, that is the meaning of this law. And third one is also very important. All the laws are very important. So third one is the cube of the mean distance. Mean means average. Mean distance r of a planet from the sun is proportional to the square of the orbital time period. Or time period t. That means orbital time period means how much time it will take to complete one rotation or one course. See, for the Earth it is 365 days. So like this. So if I say this is the elliptical path, so the radius will not be same. So here planet is here and the distance was more. Now when the planet will come to here, the distance will be less. So we have taken the average distance. The average distance is r. Okay, and the planets and the sun are proportional to the square of the orbital time period. That means you can say that the cube of the r means r cube is directly proportional to t square. Or you can say from here that, or you can say r cube by t square is equal to constant. So there are the law. So with the basis of this law, actually the inverse square law has formed. Now we'll come to the point that how the inverse law or square law has been produced. What is the inverse square law? Inverse square law is f is directly proportional to 1 by r square. So we have taken in the formula which we learned in the previous class, that f is directly proportional to 1 by r square. How he took this one? F is directly proportional to 1 by r square. That is the inverse square law. Now this is the inverse square rule was used by Newton in giving its famous formula, like universal law of gravitation. Okay, so let us take an example of a stone. And stone, you are revolving or you are rotating the stone in a horizontal circle. Suppose that the orbital velocity of the stone is v and the radius is r. Then the force on the stone will be f is directly proportional to v square by r. I'll tell you this. I'll draw you this one. So suppose this is a stone, you are revolving in a horizontal plane. So this is the stone here. There is a thread with that stone is tied, and so now the velocity of the stone is v, and the force which will work towards this center, that is known as the centripetal force. You already know. So there is one formula of the centripetal force. That formula is F is equal to mv square by r. So you write m is mass is constant for the stone. So you write F is directly proportional to v square by r. So that is the force will work. Force is directly proportional to the v square by r. And now you know that v is equal to how much? Total, this radius is r. The total circumference is 2 pi r. And time period taken, suppose t is the total time period taken. So now you can write v is equal to 2 pi r by t. Okay. And t is equal to time period. Now squaring both the sides, you can write v square is equal to 4 pi square t square into r square like this. So 4 pi square is already constant. So you can write v square is directly proportional to r square by t square. Okay. Now what we'll do, we'll multiply the numerator and denominator with r. So we'll do like this. So yes, nothing is there, that means yes, 1 is there. Okay. So you write directly proportional to r square by t square. Instead of 1, we'll write r by r. So what will write? What will come from here? Will come v square is directly proportional to r cube by t square into r. Okay. So that we got from here. Now, from the Kepler's law of planetary motion, already we know that r cube by t square is equal to constant. So what you can write from here, that v square to write as r cube by t square is equal to constant. So v square is directly proportional to 1 by r. Okay. Now we got this one. Now see in the formula, this one, in this formula, f is directly proportional to v square by r, and v square is directly proportional to 1 by r. So from, if you substitute the formula v square value here, then what will get? So we'll get, so using the formula, right, using the formula, f is directly proportional to v square by r. You can write f is directly proportional to v square, will put 1 by r, so 1 by r square. Okay. So this is the inverse square law, this formula scheme. Now, I think you'll face some complicacy here, but just remember this one. This is the force acting towards the center, is F is directly proportional to V square, where there is the derivations is not there in the syllabus. So like this way the formula, actually the inverse square law came, Newton derived. So like centripetal force you already know, I told you, that is known as the center seeking force, which is always working toward the center. Okay. So this is the like in such in such motions, all the moons around around Earth is due to the centripetal force is revolving around the Earth. Okay. So according to the Newton's third law of motions, to every action there is equal and opposite reaction. As the Earth attracts the moon towards its center, the moon also attracts the Earth towards its center with a equal force. Okay. And the sea tide is an example of this fact. Okay. So this is the explanation of the Newton's inverse square law. So today is up to this. So thank you very much.